Um, so you think you wanted to start with the diffs then? Is that a good place to start, or
Sure,
um,
yeah,
do you
I
have
can
that
walk
ready?
through the diff. I have it open, yeah.
Okay.
So I think there are two, or yeah, the useful diff is to compare the CycloneDX 1.5 schema
Okay.
with the CBOM 1.1.
Okay.
So let me share my screen. You should see my screen right now.
We do.
Okay. Okay, great. So this is our difference here between the core schema and the CBOM 1.1. Right. I mean, one thing is, I mean, it's a different URL, right, where the schema is on. It's a different JSON file, right? I think once there is an upstream, that will there will be no difference anymore. And here there is the BOM format here, which is in the core schema just CycloneDX, because we have right now, it's an extension to it. We have CBOM, right? So that you declare it's CBOM. I mean, also there, I think if there is an upstream, there won't be any I mean, there isn't a need for this additional enum entry there. Other than that, look at the next diff. So the integration that we have is basically into components, part of the core schema. So we add just one field in the enum here, that's crypto asset. So we think that's a good point to add anything about crypto. It's a component, kind of similar, like there are applications, frameworks, libraries, and so on.
Mm-hmm.
And then the idea is that if you have crypto asset as a component,
You'd have crypto properties, right?
you have the crypto properties, which in this case it's under definitions. So if we go down here, okay, that's, I think it's just at the very end. Yeah, here we have crypto properties, which in our case now it's an external reference. So we have a separate JSON schema that defines crypto properties.
Right.
And that's I think one of the discussion points, right? If that's the CycloneDX approach to have that defined externally or not, right? But I think if it's not externally, it would be just defined here, right? As a longer structure.
Okay. Let's take a look at I guess let's take a look at dependencies maybe first.
Mm-hmm. Right. So we have this dependency type here added, which is under dependency. So the idea there, I mean, there might be something different, right, to achieve something similar in CycloneDX, and then it won't be needed. But the idea is basically to be able to differentiate between, let's say, a static view. So let's say we have cryptography. If we take a library like OpenSSL, contains a lot of different algorithms implemented there, which is useful information to capture in a CBOM, we think. But it's not always the case that all these algorithms are actually used by the application. So for that purpose, we have right here dependency type. We have these two types. One is implements and one is uses, which should allow to have this, would say, operational view at the end, right? So if yeah, not in an operational view, we would be interested if what is actually in use and not just what is there as a crypto asset. And I mean, I know there is also operational bill of material, for example, that might go into a similar direction, right? And might use something different to achieve the same goal, right? So I think that's something certainly for discussion, how to achieve something like that. If that's a way to go, right, with dependency type, or if there is a different approach that is maybe in line with CycloneDX.
Right. So I'm just trying to envision this. So we've got, say maybe we got AES 256 or something, and you've got a couple different libraries. You could have that one component that references like AES 256. And then you could have like multiple dependencies. Maybe one dependency actually implements that, and another dependency actually uses that. Would that be the use case for that?
Yeah, it's yeah, kind of. So if you have, let's say, if you have a library like OpenSSL, you have AES-256, you have MD5, right, all
Yeah.
implemented. And then you have an application, on the other hand, like a web server, which uses only a subset of these algorithms. So that would be the
Yeah.
I think
for use.
I think for just one SBOM, maybe there is only, I would say it's just one option, because you just do a snapshot from the current view. So normally you just have a static scan or a dynamic view on it. So there shouldn't be like two ways to describe that. It's possible, I guess, from the schema perspective, but just from what you're doing, if you just scan the static library, you only have the implements view. And if you looking on the operational side, then you would just say, okay, I can just say now what is used, but not what is implemented, maybe. So you just have one component reference, I guess. But it's then the question when you, like, for example, in dependency track, upload multiple SBOMs from different sources, and then you will have this mixed up of implements and uses for one component.
Yeah. I mean, do you have something similar, like with just software components? I mean, I guess there is also, if you have if you have a system, right, you have libraries installed that might be just installed, but not referenced by any application that is running, right? So is this also a situation that occurs in the SBOM context? I think might be similar, like the crypto case.
I'm thinking, all right, yeah, I completely understand where you're going with this. I think, Matt, I'd like to get your opinion on this. But in one, I don't know, 1.3, I think, 1.2 maybe, we added support for evidence, and we expanded that in 1.5, and we have things like, what was the different, what were the different types of techniques and methods that we used to identify the identity of OpenSSL, for example? Did you use like some kind of manifest analysis, binary analysis, AST fingerprinting, a bunch of different other types of options? We also added support for call stacks. And I'm wondering if there's an opportunity to kind of move this over to the evidence, because ultimately a tool is going to perform this type of analysis. Like you were, I think, Nicholas or Basil was referencing, like, some kind of static analysis tool that would look at the code to figure out like what, like, does that OpenSSL implement or use a particular algorithm? That might actually be a really good place in the evidence. And then we can also potentially reuse that whole confidence in that whole thing. Thoughts on that?
Yeah, sorry. I'm on vacation, so I was trying to rearrange some windows really fast.
Rearranging windows while on vacation. Oh, okay.
I have to retreat to a corner bedroom to escape the chaos. Yeah, so just an aside, pardon Basil and Nicholas, but so the actual place I'm at, which I couldn't remember last week, is called Apple Canyon Lake. Apple Canyon Lake, if you've ever heard of it. Anyway. So I think the topic, and I talked to Basil about this weeks ago. is that I think the future of bombs are graphs. I mean, it's all about the graphs. And we've resisted basically typed edges on the graphs for a very long time. And I really haven't argued for them at all. But I think that this dependency type needs to be done for a 2.0 version. Clearly, the question is, is there enough? Are the use cases strong enough now to warrant adding this here? Because that invites a lot of people to say, oh, I have a dependency type too. And then all chaos breaks out. So the question is, when do we open the floodgates? I think that's the question. I think that evidence, for these use cases, we could shoehorn in these things into an evidence thing. But over time, people want to know as much as they can from the graph, the dependency graph. The question is, when do we open the floodgates?
Yeah, I think before we do that, we'd have to build out a bunch of use cases for expanding on the dependency types. If there's only like 1 or 2 use cases, then I don't know if I can.
Well, that's what I mean by the floodgates, is that because then every group we've done will say, well, my artifact, my component or service has a different dependency type, and that opens up the entire spec once again from all aspects.
Right. Yeah.
Because I know I would for formulation, for the manufacturing stuff, right?
Absolutely.
Because the main, for me, that was about tools. When is the tool used? So the dependency is ephemeral. So I want some ephemeral type of dependency, So there you go.
Yeah, understood. But yeah, we separately outside of this group, we should probably start capturing the use cases for that. We're going to be working on 1.7 after this is done. 1.7 has nothing to do with bills of materials and has everything to do with what the application does. And I'm not sure how we do that, because again, it's I think Cyclone is kind of moving toward being a spec that's capable of, like, quote unquote software transparency, right? And a bill of material is one way to do that, but it's certainly not the only way. And being able to cover a lot more cases other than just what's in this thing is kind of where we're going. And 1.7 is going to introduce this concept of blueprints, which basically describes what the application does at a very, very high architectural type of level. I don't know if dependency type actually fits into there, but post 1.7, we need to seriously start thinking about 2.0, because there's like design decisions that I would like to revisit.
Oh yeah, I mean, like I said, I think that the graphs are the future, and the more ways you have described the relationships, the more powerful the less things you have to know the domain to understand.
Yeah.
I think the interesting thing here that Nicholas and Basil did, which caught me off guard the week previous, was how they basically separated out the schema for CBOM, and
Right.
I think that's very clever. I just know that I've been. I think that we should think about offering a flattened version where it's inline, as well as a reference version. And I'll say this is I'll say why, because it's about offline validation in my case. So when I'm using the schema to validate, I want to work on a disconnected environment like a network disconnected environment. The problem is JSON schema is not very good. I don't know if XML schema is very good at this either, but when you give me a network address saying this other schema is on the network someplace, I can't access it.
Yeah.
And so having an inline version is so valuable to me to work on a disconnected network.
Yeah, absolutely. I agree.
And
Um,
and JSF stuff causes me that problem today. So
yeah. Well, with the, it all also goes back to the library that's also responsible for that validation, right? Like if you look at like the Java library, for example, you can validate. So we've got the SPDX, which is the external license IDs that we do strict validation on, and then we got the JSF, both of which I think are external. And the Java library completely does that offline, right?
yeah,
Because
all the
we've
library, all the libraries do it. All the libraries do it. That's the way.
yeah. But you have to like write your library to be able to do that. And if people are grabbing, just the schemas and creating their own without necessarily taking these use cases into consideration, then yeah, you're going to have kind of an issue when it comes to validation.
Yeah, I opened an issue over a year and a half ago against the library for Go, and no one's even looked at it.
Oh,
So
really? Okay.
I was actually thinking I might need to fork the code myself.
Well, I mean, Nicholas kind of maintains that. I know he's been kind of consumed with
No,
other
not
things
that
right now.
lab. It's not that library. It's not that library.
Oh,
And
it's a
it's
JSON
not the,
schema library?
yeah.
Oh,
It's,
okay.
it's the one Google. It's the one Google uses as well. I know. So anyway.
Oh, okay. All right. Interesting. Okay.
Yeah. Actually, I
So
feel bad
let's-
because I haven't not volunteered to help fix the CycloneDX Go library at all. So my code's ahead of that right now.
Oh, is it? Okay. All right. Yeah, I know Nicholas has been Nicholas Duster has been consumed with dependency track lately.
No, but I think my main concerns, I think these are esoteric things, given the use cases we've heard. I don't think there's a lot of use cases. I definitely see a discussion about how we could, describe the evidence and describe more of the dependencies there. I
Right.
think my main concern is, again, what I cited last week, which is getting more eyes on this from different, to bless this basically. And how do we get those people in the room and looking at it? And then I want Jan to look at it because I think that this view of it that Basil and Nicholas have created, where everything we see just the delta against the base spec, will be very helpful. But I mean, the earlier the better we get those opinions, the better off we are in getting this out more quickly. So.
Yeah, I agree.
Yeah.
I had a LinkedIn post the other day that actually invited people to participate. I honestly think that a lot of people just I don't know, just my assumption, but I think a lot of people actually haven't thought this through. I think IBM was certainly ahead of the curve. I actually have this requirement kind of at my employer though, because we're going through some things with trying to identify cryptographic assets. So this is very timely for my employer, but I don't think every software vendor is there yet.
I think
so,
I think that maybe I don't know if there's what the process is, but maybe how do we bless it a little more?
Yeah.
And get people to pay attention to it. You know what I mean? How do we make it more? We got a working group going. Is there a way we can do like a preliminary release or something, or a draft release or something like that, saying, get the RF, I guess there's the RFC period, but that's usually more of like everything's done, cooked and done mostly.
Yeah.
But how do we get eyes on it? We can write blogs, but I think I think at this point is, scratching my head. It's still about, extending personal invitations to the individuals, the list we got from Michael Osborne and whatever else we can find.
Right.
I know I linked that paper to you as well, which had names on it, but
Right.
Personal invitations mean a lot. It's kind of like the psychology 101. If you invite people by name, dear Matthew, would you send money to my bank account in Africa? People respond to that. So.
Let me give you that account number.
Yeah, exactly.
Let's see.
I mean, just to round this discussion up, we were planning to also open source some tools around this CBOM thing, and especially scanning tool, and also like from the research point perspective, plan to make a little bit of noise with that, and also like aware that there is this format and what you can do.
Nice.
But I think sadly, this is not the roadmap of our business unit currently. So yeah, there's not an opportunity to use it.
I mean, well, that's interesting because, we don't necessarily have incubation projects that I'm aware of in OWASP or CycloneDX, but if there are tools specifically around this work and can be versioned the same way, could they be released under the CycloneDX project?
We theoretically could, sure.
Yeah.
So that door is open for you if you want to do that.
That's good to hear. Yeah. As I said, I think that's currently not possible, but maybe in the future.
Yeah. Okay.
But I think what's possible is probably more like the tooling around like parser, right?
Right.
Parsing, just the possibility to actually produce C or S bombs, including the C bomb extension, things like that.
Well, I'll just tell you, I'm working on a pull request now where I added your schema to my validator. So
I think there's also opportunity because this is, as I was looking at the spec last week, this also kind of ties into some of the work that we're going to be integrating with Serif, which is a static analysis format. It's an OASIS standard. But anyway, the point is that your typical static analysis tool, especially one that does source code based static analysis, is absolutely going to know the difference between implements and uses. So we could theoretically go to other static analysis tool vendors or open source projects and pitch the idea to them, because I'm sure they would be able to, without a lot of work, because they're already capturing this stuff in a graph, be able to output this particular format and have that nuance of implements versus uses, because again, most of these tools, other than like a simple grep tool, but most of these tools create like an abstract syntax tree, so they absolutely know whether or not something is implemented versus is being just used.
Yeah, hearing Nicholas talk about like the tooling plan, touching the tooling plan for like IBM and things like that, and hearing the static analysis set in the same sphere, it goes back to a lot of these things IBM and others might want to do. They might want to be proactive. So a lot of these things may not be found through static analysis. A lot of these things might be proactive. We're a manufacturer producing these things, and we want to be proactive. So again, that's where the evidence, it's not really, it's not evidence of a scan or evidence that's there. It's actually proactive, saying this is the dependencies. These are the dependencies. We're declaring those things. Yeah. So I think that's the case.
Let me ask you a question, and I don't know the answer. So how would you describe a situation where maybe something old like I don't know, triple des or something? How would you describe an instance where triple des is used, however, the application is configured in a way where it's never going to be invoked?
Well, I think that goes back to dependency types. So you can declare that there's it's a traditional static dynamic library linkage issue, and you can always say that I have a dependency on this library, but it goes back to the call graph you said. So you have different SBOMs that indicate what was actually called versus was actually what the connectivity is. I've got a road that leads to this town, but I never go to the town,
Right. And the reason why I bring that up is because we've got new data components for configuration. How does the data type for configuration tie into cryptographic assets? That would be one question that I have. Can we use that in some way?
I mean, a
Yeah, I mean,
configuration is a good, I think that's a very good point. I mean, a lot of cryptography, what is used is actually in configuration files, right? At the end, right? Either in already in a source code repository or at runtime. And the way we see it also is, I mean, you can have different scans, right? One static analysis, one scanner looking at the configuration file. And what you could actually do is if you have a scan with a configuration file that tells, okay, triple des is actually not in use, right? You would not include those labels, right, in the dependency graph. You would still have if you combine it with a scan that lists all the algorithms in the library, right, you will still have that implement labels, and you will have the usage labels done by the configuration scan, right?
Right. My concern is that like an SBOM should be like if you have an application and that application is like 1.0 of whatever, you're only going to have one SBOM of that. And if you want to be able to describe the cryptographic assets for that particular application, you need to be able to do it in a way where you take in consideration the default configuration of how the application is delivered, and then also support a use case where that configuration can then be overridden or changed.
So I'm saying that this problem with configuration files is a general problem. I mean, this is the same thing I have with formulation, where we have like we're doing a build, and the build is completely dependent on how you configure Kubernetes, how you configure Tecton, and then how you configure your pipeline and your tasks. So it goes back to a dependency graph. You want to have a dependency graph that says this task depends on these are configuration files in my mind are inputs or parts of them. So you might even have snippets of a configuration file that have parameters, key value pairs, or whatever it might be in a YAML or some other JSON. And the question is, you want a dependency graph that can be as granular as possible. Say this key value pair affects, trigger is connected to this code in some way. That's what it really. It's a general use case. It's not just specific to encryption or cryptography.
Yeah.
Right. I'm just wondering if there's an opportunity here instead of the dependency type. I'm wondering if there's an opportunity here because everything out of the box for an application might just be implements because nothing's enabled, or might everything just be uses, but you change the configuration and now your SBOM is not accurate, which is my concern.
From a declarative point of view, I think I think the dependency graph is always the cleanest. I think it's a dependency, but it's not. What's the type of dependency? It's a possible connect. It's a dependency, but it's not actually realized. So you still declare the potential dependency between these things, a configuration file, and some library or some usage of it, and then that's why you have multiple SBOMs. And I think you said it yourself. You have something that after the fact, the call stack stuff was actually called and used. And the dependency graph never changes. It's just the realization of that dependency graph that it was actually that edge was that road between the two things was actually used, basically.
Yeah, I'm just wondering if there's an opportunity to use the configuration data types to actually express what algorithms are enabled, which ones are disabled, that sort of thing in the configuration itself, and tie that into.
Yeah, absolutely. So that's where snippets would come in. You could, at a granular level today, you could reveal dependency between a configuration file and a task or a piece of code, if you will. You definitely can draw that line, right? And the question is, how descriptive do you make that line, that edge?
Right.
That dependency.
Right. Yeah. But if you did that, you wouldn't need the dependency. I'm sorry. If you did that, you wouldn't actually need the dependency type, because you'd be able to express a lot more granular type of configuration use case.
Well, I think you need the dependency type because code, it's about interfaces. The data is passed through boundaries. and those boundaries are interfaces. So you have, and that's a function call, that's a library call, that's a library entry point, whatever you want to call it. And that's where you draw the edge. You say that these things are passed along the edge from this static value and a configuration file to the edge of a component at its boundary, right? I think that I still think that 100% will argue all the way to my grave the most elegant way to do that is through a dependency type. It's a basic graphing.
From an OBOM perspective, though, you'd actually have to. From an OBOM perspective, you wouldn't be able to just specify the configuration is my issue. You'd also have to like overwrite the dependency graph, which doesn't make a lot of sense to me. If you're changing configuration, why would you have to also change your dependency?
I don't think again, I don't think it's an override. I think it's a moment in time thing. It's a snapshot. So I think you have a road where these things could but it was, what road did you actually trace? It's the Google map. What you have these routes, which routes are in gray, you never use them. And then at the end of the day, you take a snapshot and say, what route did you actually take? And it's the routes that are in blue and bold and the roads you actually took. Right. So if you're drawing a map of your body and all the synapses in your body, you would include all the if you want to map your brain, all the synapses are there. The question, if you were proposed, given it, you visualized something, you smelled something, and you came to a conclusion, and you said, what pathways does it actually take? That's a different point in time snapshot. But it doesn't invalidate the fact that those other connections exist, because those pieces of information are both valuable, because I need to know that as the inputs change, that dependency graph exists, and it might cause other pathways to be fired or be used.
Just to explain for actually our specific use case for the crypto evaluation and detection and all that stuff, we will have a static CBOM until it will be chipped in a container image in total format, and then appears on the operational side. And there, the only reason why we want this dependency type is to be able then to distinguish between or filter out the not used static parts. But we don't actually have to do our use cases. We don't actually have to state that again in a CBOM. We can just read the CBOM, filter, do our analysis, and that's it. If you want to export it, then we need again this dependency types to be able to express what we did there in this process. But just from the dev side to the ops side, we may not need the dependency type there in the first place.
So you got one use case where you need it and another use case that you may not?
No, I would say if we have it, it would be beneficial, because then we can better extract and export the stuff we do. But it would not destroy our use case if we don't have dependency types there. So we can still do what we want to do.
If you don't have dependency types, you would need to track where the CBOM came from, right? So we would have, if you create a CBOM on the operational side, right, you would need to know, okay, this is actually now capturing usage, while the static analysis captured implements, right?
Yeah, but
track of it externally.
Yeah, exactly. But normally we don't export something on the operation side. There we do just the filtering. Normally just from the static side, from the dev side, then you do something on the opt side, or before you deploy it, you analyze the SBOM and all that stuff. So, but if you want to export it, then we have to use those dependency types.
Yeah, if you export it, you want to interpret it just looking at the CBOM itself, then you would need it, right? You would either need, okay, you need to cut some edges, right, that are not used, and then indicate, okay, that's now the operational side, or you need to have you need to export multiple CBOMs or SBOMs and indicate this is now the static view and this is the operational view, to be able to combine them again.
Yep.
That. Or ideally, I mean, if there is the possibility to have dependency types. You could export just once C-bomb or S-bomb and express all of it just in one in the schema itself.
Yeah, it's the only example I have for OBOM. To be honest, Steve, is what we have in the BOM examples. I was actually looking at it yesterday. So in terms of operational BOM, maybe you can help me out. So to me, it's just basically what properties, what configuration, what are the configuration values that I have. Is that primarily what it?
Yeah, and this, keep in mind that these examples are prior to 1.5, so some of this might actually be better represented in a configuration data component.
Yeah. So formulation, we're assuming that everything you did was operationalized, and then we have a workflow, right? So
What's that?
So like
right,
in
yeah.
formulation, everything's operational, because basically we're saying that this was the configuration that was used, right?
Right.
And we actually draw that in a dependency graph, and we say that this configuration, but we actually do it in a different way. We say here are the inputs, and we have outputs. So we actually have inputs and outputs. So we actually show the progress of the data through the dependency, the components, right? That's how we do it formulation. Yeah.
Right.
So I mean, yeah. So declare this. I mean, you can declare. I think the static graphs or the manufacturing graph should be as complete as possible, and you can always describe, through operational BOMs or through formulation, the exact process of how these things. You have two ways of doing it. Actually, you can do both. How this data flows through the system, basically. Because basically formulation is split for manufacturing, but it's a workflow. So your workflow could actually be, your workflow can actually be handling a procedure call, a function call, like this configuration or the installation. So workflow is designed to actually handle all those cases. It's a general workflow. How do you get data in? What tasks are run? A task can be a function call, and you can describe your inputs and parameters and what's the outputs, right? You have two ways to do it today, basically.
Yeah, my concern, I guess, is that I don't really have a concern about changing the dependency stuff. I mean, I'm not concerned about adding a new type there, especially if it's optional. That doesn't bother me at all. What bothers me, what concerns me, is being able to document to an end user who doesn't know the CycloneDX specification all that well, and tell them that just because this field is there doesn't mean it's going to be true. Because again, configuration.
It might be
that's a problem.
It might be my poor brain, but as soon as I started looking at SPDX first because I didn't even know CycloneDX existed.
Yeah.
So I started tuning it. But as soon as I saw the spec and I saw RDF model, well, I know RDF models going back 20 years. So I really immediately grasped onto that. And it was easy for me to conceptualize different graphs. So I think that people educating, so many people are going to infer stuff from graphs. And I think that's the way it's being pushed at, OpenSSF with Guac, and Google's pushing graphs. The more things you can describe relative to graph and say this is a different type of graph based upon a different scenario, the easy, to me, it's hard to explain CycloneDX now, because it's like now you have all this model card data that's separate. You have to describe how it relates, so everything's a one-off basically. Whereas if you can describe everything through a graph, and so you understand everything through how the relationships work, to me, that's very simple and elegant. And I think that fits my programmer brain better.
It is simple and elegant. However, it also introduces a massive amount of complexity, which is also what that team is dealing with.
It's the same trade-off in programming. It's typing complexity, JavaScript versus strongly typed things versus weakly typed, right?
One of the benefits that when we set out to do this, and I think I mentioned this in several podcasts and some other stuff, but we did not set out to create the perfect model. That was not our intent. This is, and CycloneDX has far from a perfect model, and that's by design.
Yeah.
The model is done in a way where it's really difficult to shoot yourself in the foot It's very prescriptive on what it does, so that if you are a developer and you just want to quickly write an implementation that supports CycloneDX, you can very easily do it, and know that there's a really good possibility that your tool is going to be compatible with all the other tools. The other specification doesn't have that luxury, right? They have incompatibilities all the time between tool vendors and open source projects. It's one of the reasons why they have DocFest, which is basically a coming together, because the specification is so
Right.
complex. We've
Well,
avoided that on
Yeah,
purpose.
and that's the saving grace of CycloneDX, and you've heard me preach 1,000 times about the use cases. Is like you find the use case that you need, and you've got an example, and you know, and then the data looks familiar to you, right, for that example. And that's
Yeah.
exactly, I think that all the things you raised today just beg for, like, we'll get the use cases down, you know, capture the questions you've asked about how this relates to evidence, how this relates to operational stuff. And as long as we hash out, you know, the base examples and say how it relates to that data, I think then you for people working in this realm, they can gravitate to a set of use cases, and they can have examples of how the core CycloneDX data and schema relates to these things, right? And I think that's consistent with how CycloneDX has been developed, and it works for me. So anyway.
So let's flesh out a use case, or actually just two use cases to begin with. I think that would be one, and we can build on the first use case. One is just a software vendor actually delivering software to market, whether it's an open source project or commercial vendor, doesn't really matter. But you're delivering software, and it comes with support for various algorithms, and it has certain ones configured out of the box and certain ones not. Then we can build upon that use case where the end user, the software consumer, actually then configures the application once it's deployed, and then obviously modifies that default behavior, right? So let's take that first use case and then apply that second use case on top of that, and see how the dependency types kind of work, how we might want to use configuration to kind of express some of these things in 1.5, and how the OBOM kind of ties into that. Does that sound like a good path where we can just start looking at the use cases and see if this model actually works, and maybe where it falls short? Maybe you would add some other things to it. Does that sound like a good path?
I think as long as Nicholas and Basil are shaking their heads, yes. And because they're the only people that probably have actual data, and they can, you know, if we can, you know, it goes back to the, you know, I've been looking at BOM examples. You know, basically we just need to start creating some BOM examples, and if Nicholas and Basil have captures of some things they've used for like a scanning thing, and we can anonymize that data or simplify it in a way where we can attack those variations, I think that's what gets us to the end result most quickly. Yeah.
Do you guys have like a hello world type of example for CBOM where you actually maybe represent some non-quantum safe, or maybe just some weak algorithms in a software package?
Yeah, we have, I mean, part of the repository, there is an examples markdown that illustrates basically how to use the different properties there. And there is, or there was, I think, at least in the first version, also an example with two use cases that illustrate uses and implements. Basically, one is the view, or was the view of a library, right? If you ship a library, you want to express what algorithms are implemented there. And then the second is the view of an application that is either, let's say, hard-coded to use certain algorithms or configured to use certain algorithms on the operational side. So I think that's probably what you could use and expand on, if there is, yeah.
Okay, that sounds like a good starting point.
Like with configuration and something in CycloneDX to express something like that.
Yeah, so I think that if we get a couple, you know, hello world use cases, maybe a little more robust than hello world for this group, and we can bring them and go through them next week, and then we can figure out, you know, make sure then we create the variants that Steve hit upon operationally, you know, just getting the use cases discussed and you know, published someplace where we can all look at them, I think will be, and then create derivative use cases from those is probably the concrete next step.
Yeah.
It's probably that was probably well understood. So partly for it's kind of like my summation. Anyway.
Yeah. Also with the new, I mean, with the current version of the schema, we did some changes to not having to express everything with a dependency, namely things that are, let's say, one asset type that we have is a certificate, for example. There you have a signature algorithm that is tied to a certificate. So we had the first approach was to just model that with a dependency, right? So that it uses an algorithm. And now with the current version, we have a crypto ref as part of the certificate properties, where we can directly link to a bomb ref, basically, of an algorithm. So I think that simplifies things a bit, so that you don't have to model everything with dependencies and dependency types. So, and yeah, and I think would make sense then to look at those two use cases.
Yeah, I definitely want to pick. I definitely want to emphasize the fact I don't want to see necessarily a hello world use case. I want to see something that's, you know, components, has some small number of components and has some richness to it. Something that will, you know, we can, you know, in a short runway, get the most value out of it. Because what I'm seeing for myself is, you know, a push in the next 2 months, clearly, by end of September, to be able to have use cases that we can put out to people, blog about, and also write tooling against. I'm excited, you know, to be able to say, you know, let's bring in a bill of materials with quantum safe type of information, cryptographic CBOM information, and be able to have a run a utility saying quantum safe or not quantum safe, and create a report or something. I think that closure has power, and I think that will get the attention that we need for the RFC period, and it'll get the attention of governments and other agencies who are concerned about this space, right? Yeah. But yeah, so not hello world, but more like, you know, a good three-course meal or something like that.
Yeah, that's fine. I just didn't want to get into a situation where we're trying to model all of OpenSSL.
No,
right?
no.
That's too complex.
I care more about I think that, like I said, it's more about in 2025, is my stuff quantum safe or not? And what does a good bomb look like that has the correct declarations and dependencies and everything described, versus something like with a SCA tool? If I scan something, you know, do I see things that are not quantum safe? I think, to me, that's what resonates to me as an end user.
Yeah.
Right.
Yeah.
One I think very good use case is the CNSA 2.0 advisory that is out there that, yeah, it tells exactly that by 2025 you need to support quantum safe algorithms, and they have a list of algorithms that need to be supported. And then by 2033 you must exclusively use those algorithms, right? So use is in that wording there, right? So supporting something like that and those two nuances,
Yeah,
there,
I mean,
it would be really good to be able to.
Yeah, I am getting chills, because I think that if we can show those things, we are heads above, you know, your work, thankfully, is there. But in terms of CycloneDX, it elevates CycloneDX so far above SPDX. And yeah. It's
So one thing that and I was thinking about this earlier before the call, Matt. One thing that might really be interesting, I had two ideas. One, we have support for hardware bill of materials, and we use properties for this today.
Yeah.
But for hardware bill of materials, we have certifying authorities, right?
Yeah.
Like which government and which agency within that government actually certified a given piece of hardware. Like in the United States, that's in some cases FCC, maybe Underwriter Laboratories, etc. In Europe, they obviously have their own. But we might want to do something like that with cryptography bill of materials, because like NIST, for example, has their guidelines, but they're not the only government in the world, right?
Yeah.
Other governments also have their kind of requirements, which brings me to my second point. There might actually be an opportunity for us to kind of leverage the work that we're doing with the attestations, not the attestations themselves, mind you, but the standards and requirements that are kind of the prerequisite for the attestations to exist in the first place. So you could theoretically link these things back to given requirements in a given standard. So for example, NIST has a standard and it requires X algorithms or prohibits X algorithms. Well, then you could express that in CycloneDX in some way.
Yeah, I think that, you mentioned Seraph before. I think for me, the grail, and I push this at OpenSSF and software projects, is the OSCAL stuff. And OSCAL is what governments pay attention to. It's representing those terms in terms of policies. And I know that OSCAL has what are called implementations for like PCI or for whatever the security standard might be. I think that's what we're looking for, is that closed loop, saying here's whatever my framework is for evaluation, and here are the controls, and here are the requirements, and those can be represented in OSCAL some way. And on the back end, you have Seraph that you can basically have some analysis that proves that you adhere to those things, right?
Right.
So,
My issue with OSCAL is, it's fine.
it's
One, it's a NIST thing, and
Yeah.
two, it's security specific. And cryptography isn't always about security, right? You've got privacy and all kinds of other use cases.
Yeah, no, I agree. And no, I completely agree with your analysis, Steve. but I'm saying it's the best we have right now. It's the concept. It's the concept is always like declarative policy, and then declarative evidence of that, right? Like I worked with the Cloud Security Alliance before. That's why I created my own audit standard in DMTF, and that's what we use for IBM Activity Tracker. It's always about being able to have some audit standard at the end, verify some policy that against some framework, wherever it comes from.
Just from my understanding, so what you were talking about is just like the SBOM evidence in total format. You want to, if they're like a kind of state this is a requirement, and then attach like a CBOM to it as a proof for that requirement. Is that okay?
And you'd actually be able to do that. Like if we designed it right, you'd actually be able to do that in CycloneDX, because CycloneDX actually is the first standard that I'm aware of that is a general purpose machine readable way to express standards, requirements for those standards, the attestations, the claims backing up those attestations, the evidence, the counter evidence, the mitigation strategies, the signatures, the signatories, etc. Everything that you would need to have a general purpose attestation kind of framework. It goes beyond what OSCAL is doing. There's certainly some overlap between what we're doing and what OSCAL is doing. The benefit from what we're doing is that we're not looking at it from purely a security lens. That's just one of many different lenses you can view things with. But ours is truly like general purpose. Right now, we are representing BSIM. We've got support from BSIM. We've got support from PCI Council. We've got multiple OWASP standards. We're in the process of doing, we've already got SSDF represented. We're in the process of doing some other standards work as well. We actually have a conversation with NIST, I think later this week or next week, to see if we can get alignment from them. But anyway, we actually have use cases that would be non-security specific, maybe like underwriter laboratories type of use cases, where it's all about quality requirements before you actually deliver something, right? And all the thousands of test cases that maybe an IoT toaster would have to go through in order to go to market type of thing.
Okay, like that.
And I said, like, again, I think that the way to unify the elements of evidence, the elements of audit, the elements of attestation, or whatever it might be within an SBOM, I still think it's through and it also marries well with SCVS, to be honest. It's a tagging mechanism. So basically, you have a tag miss regardless of your framework for policy declaration, regardless of your framework for attestation or evidence or logs or whatever you want to have, as long as you can identify the owning, the publisher or the owner of that domain, that framework, that whatever it is, and you can identify it through a tag and a URN. That's the way to go. And we just say how we decorate the SBOM and the evidence, the attestations, whatever are linked in the SBOM. We can decorate those things with one or more frameworks, so you're not limited to one framework, right?
Yep.
Through
Yeah, you can do that. You can do that today. I think we have
you can do that
for,
today. Yeah.
yeah.
So, so we can actually, even without great changes to 1.6, I think it comes to, again, it's following the philosophy you know, we just discussed 10 minutes ago. As long as you have great examples of how you do it today, people will use it, right? So,
yeah. Speaking of examples, Matt, the MBOM guide.
Yeah, I know. So if you want me to leave IBM, and has OWASP gotten any grant? You can.
Not yet, but we're working on it.
Yeah, if you can give me off the record, if you can give me an excuse to work full time on Cyclone or for OWASP, give it to me. Anyway.
Right on. Okay. We're at time. Any last thoughts from anyone? I thought today was a good conversation.
Yeah, again, to be frank, I think that, I think that if Nicholas and Basil, provide the use cases next week with concrete stuff, again, I think we need to figure out how to publish this. These meetings are still password protected and stuff like that. And I know
they're on YouTube.
Oh, really? I thought after the fact. I mean, the meeting invites actually have an encoded password in the URL, right? So
that might be true, but yeah, anybody can get to them.
I think that, as far as homework goes, I think that, I hate to say it, but you are Cyclone, and you have all the connections. We need to cast the net, and through your personal invitation, Steve, maybe if once we have the use cases in hand, publish them somewhere publicly, and make sure the CBOM stuff is kind of already public in the IBM repo. If we can publish use cases publicly and those things, and say, here's what we're talking about, and send out personal invitations, Psych 101, and say, please, I just want to get eyes on, I want to get this blessed as soon as possible, and especially Jan, from a general point of view. I think, to me, I think that IBM wants to. I mean, I'll just disclose fully. I mean, we have products that are going out. We'd love to work against a near final standard, by end of year, versus something that's speculative. So we can,
No, we're far enough with the attestation work that we're at the point now where we're just starting to prove that it works. We think it's going to work, but we're at that final stage of actually using our own spec, and so we're fairly far along. I'd like to be able to release 1.6 by the end of this year. That's the goal. Release it by the end of the year.
So again, it comes down to the three-legged stool. I think that, discounting myself and discounting you as an insider, having a Microsoft and another maybe an academic, one other big name, having 3 independent bodies, at least vet the work and have their name on it, as early as possible. And then Jan, as I said last week, he caught me off guard at the 11th hour with all the changes to and I'm still regretting agreeing to a couple of things.
Yeah.
I want him to agree to everything very early on.
Yeah,
So,
let's we should probably revisit some of those things in 1.6 too.
Yeah.
So if you want to create issues for some things, that go ahead and do that.
Ask me questions. So, and the issues.
Yeah, I'll make sure that I'll see if Jan can start coming to, because it's probably around the same time zone as Basil and Nicholas.
Asking one person from like Microsoft or someplace, that one guy, I think, targeting that one person, like it's like an Instagram social media person, getting the word influencer, that one person, they'll help us spread the word, right? So anyway.
Okay. Yeah, that might be challenging just because of the political landscape over there, but we'll see.
Yeah.
I can try.
That guy's, you know, the guy was all gung ho on the responses to email. So, and
Okay.
we
All
just
right.
need,
Ping me
Hey,
offline, Matt.
we just need to know why that person can't come to this call, you know, so.
Okay. Yeah, ping me offline, Matt. Let's follow up with that. I've got to talk to you about a few other things as well. So
I'll probably
um,
get back next week.
okay. Well, I hope you have a good rest of your vacation. Thank you for spending at least an hour of it with us instead of, you know, enjoying Fiji or wherever it is that you're at.
Oh no, it's in like it's a funny lake in the middle of near the Mississippi, near actually half an hour from the Mississippi, I guess.
Oh,
Didn't even
okay.
know.
All right. Very good. Well, again, thank you so much for your time and contributions, everyone. And I'll go ahead and post this video later today, and look forward to kind of diving into some of these use cases next week.
Thanks, Steve. Thanks, Nicholas.
All right.
Thanks.
Cheers. All right.
Thanks.
Bye-bye.
Thank you.
Bye bye.
Bye.